Okay, today I had a little bit of I decided to build a capacitive discharge charging circuit for a couple of batteries that I've got here. Both of those batteries were old and destroyed. They wouldn't hold a charge anymore and they won't start a car or anything like that. So I thought, I've been thinking for a while about how to go about making something to perhaps have a go at discharging a cap into them, and today I put it together. So what I've got is that high current transformer driving the low current or low voltage primary, and I'm also tapping out from another low voltage primary, so it's going in as 2 volts, it's coming out as 21.7 volts at the moment. Well, it's going in at some voltage, I'm not sure what that is at the moment, but anyway, it doesn't matter. So then that's coming out there AC and going into either side of the batteries here. One side's connected to positive, the other side's connected to negative. And then from the center posts I've got leads coming through to this couple of rectifiers here. Let me get this right now. This is the positive side here going to the cathode of the rectifiers. So the positive wire goes to the white stripe, the negative wire goes to the black side, to the anode of the diodes, and then the other end of the diodes pair is connected together. Connected to that same leg on the diodes is a capacitor. It's a polarized cap and it's connected in sync with the posts, so that the positive side of the capacitor is connected to the positive terminal of the batteries, the negative side similarly, so that when the AC signature comes in, when this side is negative, and so the incoming is positive, when this side is negative, swings negative, the energy flow is then directed through the diodes and out the other side into the cap. Not into the cap, into the batteries. So it goes into the negative side of the batteries through that light, and then when it swings positive, it charges the cap, and the cap then, when it's when the voltage reverses, it then discharges through the battery, through the light of the batteries, and vice versa on the other swing of the AC cycle, as you can see here on the scope. This is the point at which the SCR turns on. The AC, if you can imagine, the AC sine wave would be here, so this is where it's turning on. It turns on to there. When it then turns off, the capacitor discharges, ready for another turn on pulse here on the other side of the cycle. When it turns off, the capacitor discharges, turns on. So you can see how this section here is the input voltage, and this section out here is the discharge current from the capacitor. I can demonstrate that by changing the cycle, the frequency cycle with the light dimmer. I can adjust up and down so that it draws more current or less current. It's actually drawing 900 milliamps at the moment for the full circuit, which is that light, that fan that's keeping the triacs cool, and that transformer is also being kept cool by the fan. So 900 milliamps. It's driving 13.5 volts AC into the batteries. Well, the batteries are seeing 13.5 volts AC. That's an indication of the current there. That's actually a 24 volt light globe running at probably about 5 watts, I'd say. It's not even hot to touch. The light is, as you can see, not real bright, so there's not very much current going into the batteries. I will, because it's AC, I can actually measure it we're here. 1.7, 1.4 amps at 13.5 volts coming from the cap. So it's quite a lot of energy going in there. 1.4 or 1.5 times 13.5, say 13, so it's 26. 26 and 7 is what? 30. 26 and 7. 6 and 7. That's 30. 36 or something. 36 watts going in. So that's not bad. That's a pretty good input surge. And on this side, the same, 1.3, almost the same. It's a different dimension cable. 1.3. So this is a single wire. That's why it's showing 1.4, 1.3. What else do we need to know? 13.5 volts across there. Oh, DC voltage on the batteries at the moment is 24.8, and that's been slowly rising. It's been sitting here for about an hour on charge. So yeah, we'll see what happens and where we can get to with this discharge pattern. That's what I was going to do too. Change this. I'll adjust the dimmer so that it draws less current first. I'll turn it right down. You can see then the difference in the change. You can see now that the on time of the SCR, the off time of the SCR is increasing, and so the on time of the capacitor is decreasing. Keep going down, and as it becomes emptying, nothing is there. The AC voltage is now down at 4.4 volts, and input voltage 20.2 volts. So you can see. I'll also do that one in. That's the input. You can see it's not actually reading any current there at all at the moment, because it's just too small, which is a mystery because it still reads 20 volts, I know. But anyway, so I'll come back up, put this where we can see it a bit easier. That's better. Come back up on the triac to where the light gets the brightest. So I'll just do that by hand, watching it in so that's about the brightest point there, 13.8 volts, 13.9 volts AC going in and drawing 500 milliamps. And you can see that the on time is very small. The off time of the cap has actually got a kink in the middle now. And if I keep going up, that kink widens. It starts to draw more current, and the light goes dimmer and dimmer as I go up higher and higher. So that's not a good thing. That kink is actually leakage through the cap. So where the kink is minimal and the on time matches the best is about where we get 12.7. I'll go up a bit. I'll go up to 13. Keep watching that light globe too, because where the light globe is the brightest seems to be the best balance at 13.769 AC, 4 or 500 milliamps. and not straight there. It's not perfectly straight, but that amount of leakage seems to be okay. And nothing's really getting hot either. I've got this little temperature gauge thingy. That's the SCR temperature, 18, 19 degrees, and the core is running at 30. I had that up to 58 before and everything melted, but that's alright, repaired it. And the connections to the high current side are warm but not hot. So yeah, that's it. Capacitive discharge current should be desulfating these batteries and returning them to usable service, perhaps. Maybe. Hopefully. Anyway, we'll see what happens.